Today, we're going to revisit the order of operations. As you are aware, the order of operations is a rule that tells you the sequence to follow when you are performing operations in a mathematical expression. The first thing that you do is you solve anything inside of parentheses, as long as there's an operation to solve. Sometimes, remember, parentheses can be involved just to show a separation between a plus sign and a negative sign. After you've solved any operations in parentheses, next you'll move on to any exponents. Those are the numbers in the air. After that, you'll solve everything with multiplication and division. But sometimes people get confused and think they should do multiplication and then division. However, it's actually you just solve them left to right, whatever comes first in the problem. Finally, you should only be left with addition and subtraction at that point. This is your fourth step, and you'll do the same thing as multiplication and division. Instead of doing all the adds then the subtracts, you'll just do whichever one comes first, left to right. We do have a few helpful hints over here that you should remember when you're doing the order of operations. The first one, follow all the steps in order. Then be sure to always show only one step at a time when you show your work. Of course, you should show all your work as you're doing these. Don't forget, you always work left to right as you do these steps. And bring down all the parts of the problem after you solve each step. And finally, when you choose to solve a problem, you can choose to use either fractions or decimals. However, if it's going to be a repeating decimal, so meaning the kind that if you solve them, they would have a bar over them, you must keep it as a fraction. Now, we want to do some problems where you try to decide which one would come first. In this problem, what should you solve first? If you said that you should multiply the 3 times 25/100ths, you are correct. Check this next problem. It's a little longer and more complicated. Which one would you do here first? If you said that you should divide 75 by 5 first, you're right. Remember, in the order of operations, we do parentheses, exponents, then multiply, divide left to right, then add, subtract left to right. There's nothing to do in the parentheses of this problem. There are no exponents. So multiply and divide, you go left to right. The first one we see is a divide, so it should have been your first step. Final one, which one should you do first this time? If you said 45 minus 12, you are correct. Remember, when you only have add and subtract, you work left to right. It doesn't mean add before subtract. It means do whichever comes first. Since the subtraction came first, that's what you would do. All right, we want to get into solving some problems. We have the same problem here twice. I'm going to solve it once with fractions and once with decimals, just so you can see both. So to help us focus, we're actually going to just focus on doing it with decimals to start us off. So here's our workspace. As I solve this, there's going to be times when I pause, and you will need to write down your work and answer the question before we move on. My first question is, what would you solve first in this problem? That's right. the first part of this problem would be solving the parentheses. However, I'm noticing in this problem that I might want to switch it all to decimals before I even start that. Right now, switch all the numbers to decimals that you can. That's right, 1/4 is worth 0.25 because there are 4 quarters in a dollar. 1/4 would be worth 25 cents. Then I'm supposed to multiply that by 3 wholes minus 1/2. We know 1/2 is the decimal 0.5. Next, we have 6/12. Now, I know that 6/12, if I divided both those by 6, I would get to 1/2. Well, wait, half is worth 0.5. Then I have plus 0.75. Now that I've changed them to decimals, I'm able to solve the problem. First step is the parentheses. We have 3 wholes minus 1/2, minus 0.5. So, when I do that, it's 3 wholes minus 0.5, and that will give me, I need to decompose, bring my decimal down, that will give me 2.5 as the answer. I take the sign of the bigger number, which is the 3, and so it's a positive 2.5. Notice I did not do additive inverse to the minus this time. The reason being, 3 is already a larger number than 0.5. It's not necessary. Now I'm going to bring down everything. This was in parentheses. You leave it in parentheses because it's multiplying by 0.25. Then minus 0.5 plus 0.75. The next step in our order of operations is to check for any more parentheses, but there are none. And then we would check for exponents, but there are none. And so then my question to you is, what would you do next? If you said to multiply 0.25 by 2.5, you are correct. I'm going to show that multiplication right now. 2.5 times 0.025 would look like this. Remember, in multiplication, you do not have to line up the decimals. 5 times 5 is 25. We get 10 plus 2 more is 12. Don't forget, in multiplication, you need to put a placeholder 0 here before you keep multiplying. Now I'm going to multiply 2 times 5, which is 10. Carry the 1. 2 times 2 is 4, plus 1 is 5. I add these together, getting me 5, 2, 6. And then to figure out where my decimal goes, I need to count how many digits came after or behind the decimal. It was 3 digits, so I'm going to have my decimal 1, 2, 3 from the end. So the answer to this is 0.625. Now, I'm going to bring down what I did not use, minus 0.5 plus 0.75. At this point, I notice that there's only subtraction and addition, and I know I'm supposed to move left to right. So my next job is to do this math problem. Well, let's see. Should I change the subtraction into an addition and change the 0.5 to its opposite? In this case, no, you don't want to do that because they're both positive numbers and the 0.625 is larger, so there's no reason we need to do that. Instead, we're just going to do the subtraction. Can you please do the subtraction? When I go to line this up, it's 0.625 minus 0.5. Now, in addition and subtraction, the decimals do have to line up. So I can add some zeros here to help me. 5 minus 0 is 5, 2 minus 0 is 2, and 6 minus 5 is 1, we bring down our decimal, and since they were both positive, I know the answer is a positive 0.125. I will now bring down the rest of the problem. It says plus 0.75, and to end this, they're both positive. I simply add these. 0.125 plus 0.75 gives me a total of 0.875. Now, that's how I solve it with decimals. If I were to do the same problem with fractions, and I'm going to work a little faster, let's see how that would look. We already have all of these as fractions. However, I will make some changes. For example, for the 6/12, I'll move it back to a half. I think that will be easier for me. And for the 0.75, I know that's worth 3/4. Now as I'm looking at this problem, I'm noticing that I don't have common denominators. However, I know if I were to skip count by 2's, 2, 4, 6, 8, and skip count by 4's, 4, 8, 12, the first one they have in common is 4. So if I can turn these ones that have halves into fourths, this will become an easier problem for me. So no problem. I know how to do that. I find the multiplicative relationship that takes me from 2 to 4. 2 times 2 is worth 4, so 1 times 2 means this top number is a 2. Same thing over here. 2 times 2 is 4, so 1 times 2 is a 2. Now I can bring everything else back into this problem. It's 1/4 times 3 minus 2/4 minus 2/4 plus 3/4. Now I'm going to go ahead and solve this problem doing my parentheses first. So when I go to do these parentheses, I notice that it's 3/2 minus 2/4. Or sorry, 3 wholes. 3 wholes minus 0 wholes with 2/4. Well, if you think about it, right now 3 wholes has no fourths. Okay, so I need to decompose to make it so there are some fourths. So instead this is now 2 wholes with 4/4, because 4/4 makes a whole, plus 2 wholes, that gets you back to 3 wholes. Now I go to subtract. 4 minus 2 gives me 2/4, and 2 minus 0 gives me 2. The answer to that problem is 2 2/4. Now I'm going to multiply that by 1/4 minus 2/4 plus 3/4. The next step I'm going to do is I'm going to multiply 1/4 times 2 2/4. Now when I go to do that, I'll write it over here. 1/4 times 2 2/4. And I know that I can change this into a fraction greater than 1. 4 times 2 is 8, plus 2 more is 10. I have 10/4 times 1/4. When I go to multiply this, I'm going to get 1 times 10 is 10, 4 times 4 is 16. Now since both of those numbers are even, I can divide them by 2, and I will get this down to 5/8. Now I'm going to put 5/8 here. At this point, I want you to connect. The fraction 5/8 is the same as the decimal 0.625. I'll bring in the other parts. It's minus 2/4 plus 3/4. Now, I don't know if you guys have noticed what I've noticed, but we no longer have common denominators. In fact, perhaps I never should have changed it to fourths yet. Maybe I should have multiplied first and then find the common denominator. That's fine. Either way works. Between 8 and 4, though, if I get them up to 8s, that will be a common denominator. So let me do that real quick. That's fine. 4 times 2 is 8. 2 times 2 is 4. 4 times 2 is 8. 3 times 2 is 6. And then I just bring in the minus and the 5/8. Now we know to finish this off, when there's subtraction and addition, you just move left to right. So first I'll do 5/8 minus 4/8. I know it gives me 8 because in adding and subtracting it doesn't change your denominator. And 5 minus 4 is the number 1. Then I'm supposed to add to that 6/8, which I know will give me 8, and then 1 plus 6 gives me 7. 7/8 is the same answer as 0.75. Now that we have finished that problem, we have one more that we're going to do together. In this next problem, it says we can solve it with decimals or fractions. If I went to solve it in decimals, can you please take a minute and change your fractions in this problem to their decimal forms? Awesome. Let's see how you did. 3/5 is worth the same as 3 divided by 5. 5 doesn't go into 3, so it goes in 0 times, and I added the decimal and the 0. 5 goes into 30 6 times. 6 times 5 is 30, so I'm done. So I know this is worth 0.6. Well, what about 2/3? 2 divided by 3 ends up being 3 can't go into 2, so I get my decimal and my 0, all that. 3 goes into 20 6 times. I'd get 18. I subtract. I get a 2. 3 goes into 20 6 times. Get an 18. 3 goes into 20 6 times. So you start to see we're getting a repeating decimal. Uh-oh. I can't put a repeating decimal into these problems. No repeating decimals allowed. Well, no spelling errors allowed either. No repeating decimals. So therefore, in this problem, I can't even solve it with decimals. I am forced into making everything into fractions. We're going to go over here and we're going to try that. This time, instead of getting common denominators from the start though, we're going to see what happens if we didn't do that. So this first number is already a a fraction. The second number is saying 0.8 or 8/10. If you say decimal is the correct way, it literally tells you the fraction. 8/10 minus 6/10. Okay, got it. Times 5 minus 2/3. Now, according to the order of operations, what should I do first? Good job. If you said solve the parentheses first, you're right. We'll do 5 minus 0 and 2/3. Now remember, I did this in the last problem. Right now the number 5 has no thirds with it. We'll need some thirds to solve it. So when we do that, we'll decompose the 5 to a 4, and that will give 3/3 over here, because 3/3 and 4 wholes together make 5 again. So we have 3 minus 2, which gives you 1/3, and then you have 4 minus 0, which is 4. So we get the answer to this is 4 and 1/3. Now I bring down everything I did not use. And I think about what the order of operations tells me to do. What should I do next? If you said that I should multiply next, you're correct. I only have addition, subtraction, and multiplication. Multiply always comes before add and subtract. So I'm going to go to do this multiplication. I have 6/10 times 4 and 1/3. I know that I'm going to change the 4 and 1/3 into a fraction greater than 1. That will become 13/3 times 6/10. Now there's some tricks to do when you multiply fractions. It actually makes it easier if you do get fractions in their simplest form. So for instance, since 6 and 10 are both divisible by 2, I could get this down to 3/5 before I multiply. It will make it an easier problem. Alright, 3 times 13 is 39. 5 times 3 is 15. 15 goes into 39 2 times, because I know 2 times 15 is 30. So if I subtract 30 from that, I'd get 9 left over out of 15. Well, hold up. I also know that 9 and 15 are divisible by 3. Therefore, the final answer will be 2 wholes and 3/5. So I'm going to write 2 and 3/5 here. And now I'm going to bring down everything else. Sometimes students think you should still bring down parentheses around this, but you should not, because the parentheses just meant to multiply, and we did that. So now we see adding and subtracting. I notice that we have some different denominators, so we are going to fix that at this point. I notice that because we're left to just minus and add, and we know that we need common denominators for that. Let's think about fifths and tenths. Well, I know that if I do 5 times 2, I get 10. So I'm going to get these all up to tenths. 5 times 2 is 10, so 3 times 2 is 6. 5 times 2 is 10, 3 times 2 is 6. When I go to do this, I get negative 6 tenths plus 8 tenths minus 2 and 6 tenths. So we always work left to right when we do addition and subtraction. This one came first. Notice these are different signs. We know when they're different signs you actually subtract. So 8 minus 6 would give us 2 tenths, and we take the sign of the bigger number, the positive, minus 2 wholes and 6 tenths. Okay, this one is a little interesting. Since this is a tiny number minus a bigger number, we're going to want to use our additive inverse to help us. We will change this to a plus and change this number to its opposite. So it's now a negative 2 and 6 tenths with a positive 2 tenths over here. Now we know when they have different signs than each other, I actually need to subtract the numbers. So if I were to take 2 and 6 tenths, the bigger number, and put it minus 2 tenths, it would be 6 minus 2, which would give us 4 tenths and 2 wholes. Oh, wonderful. So we get the answer 2 and 4 tenths. We take the sign of the bigger number, the negative. And then we might notice that these are both divisible by 2, which means the final answer is actually negative 2 and 2/5. All right, on the last problem, I want you to solve this on your own. When you get to the end of this problem, you need to show it to your teacher to get some feedback. Hopefully this has helped you. Remember, you can go back and rewatch any parts of this video to help you while you're solving this problem on your own. Good luck, IM students!